IBESS, Intro to Resources, Part 7, will focus on the calculation of the per capita footprint to better understand how ecological footprints are calculated, including their assumptions and approximations. In the second half of the movie, we will look at why the ecological footprints of people from more economically developed countries are larger than the footprints of people from less economically developed countries. The significant ideas are environmental indicators and ecological footprints can be used to assess sustainability. The ecological footprint is a model that makes it possible to determine whether human populations are living within the carrying capacity, and human carrying capacity is difficult to quantify. Here is the outline of all the available movies for the Introduction to Resources unit. Use this outline to find the movie you need for review. Now, this movie is focused here, and the details of calculating ecological footprints will be outlined. This is the second of 2 movies on ecological footprint. It's important for me to note that you won't be asked ever to carry out ecological footprint calculations, but this advanced look at ecological footprint calculations will strengthen your understanding of ecological footprints. In the second half of the movie, I will compare the ecological footprints for different countries, and this is a mandatory IB statement. Stay with this movie to the end. Remember that an ecological footprint is the area of land required to sustainably provide the resources, all the resources required by a given population, and it includes the land for crops, land for wood, the land for buildings, our urban footprint, and the land for the uptake of carbon dioxide given off when we burn fossil fuels. Now, if a society's footprint is larger than the area available, the society is not living sustainably. Now, ecological footprints are not the same from one country to the next, mostly because per capita rates of consumption are very, very different. Also, ecological footprints are calculated using local land productivity, and these vary location to location. Now, starting with per capita ecological footprints as appropriate data, we can calculate the ecological footprint of a larger population by multiplying by the population size. Pay close attention. So let's calculate the ecological footprint for a city or a large population, a country, for example. We can use the per capita footprint and the size of the population to do this. Say, for example, the per capita footprint is 6.2 hectares per person, multiplied by the size of the population, 16.5 million people, gives you the land area required for the population. This is 102 million hectares. This is the ecological footprint for the entire population. Just to be clear here, this is the ecological footprint of the Netherlands. Now, what's interesting or depressing is that when we compare the ecological footprint of the Netherlands, 102 million hectares, with the actual land area, in this case 4.2 million hectares, using this conversion to determine the size of the Netherlands in hectares, you can see that the ecological footprint far exceeds the land available. Now, the underlying explanation is the high per capita consumption of resources by people in the Netherlands. So let me outline the data used in the calculation of the ecological footprint of a given population, stating the approximations and assumptions involved. Now, you don't need to know how to carry out ecological footprint calculations, but this advanced look at ecological footprint calculations will strengthen your understanding of ecological footprints. To calculate one's ecological footprint, we must gather the data on all the components of one's consumption. We must look up per capita consumption values, typically in kilograms, for vegetables consumed, paper consumed, meat, wood, cotton, and we have to remember that we've got to account for the CO2 released by the burning of fossil fuel that's a part of our lifestyle. Remember that ecological footprint has sustainability at its core, so we have to account for our waste. but there are approximations and assumptions. Stay tuned. At the top of this slide are the components of data that must be collected, typically with an online search. But before we do that, I just want to emphasize that it's not difficult to imagine how we can convert these values into land area equivalents, because we can measure the land area required to, grow vegetables or grow our meat or grow the wood for our paper, or the land area for the wood we would use in building. And it's not even difficult for us to imagine how to account for the CO2 released as we burn fossil fuels. We can imagine that land area as what's required to take up the CO2 through photosynthesis. But how do we estimate the land area accounting for the fish we eat, or the land area for the water we consume? How does the ecological footprint account for the metals we consume, or high-rise buildings, or pollution other than carbon dioxide? So to keep things simple, let's look at the calculation of one component, the land area required for vegetable food in hectares. This is one component, and it's an easy component. It takes one small step toward the calculation of one's total per capita ecological footprint. Now you look up the data for food consumed by the average person of a country, and you multiply it by the land area required to grow a kilogram of matter in that particular biome. Now this term right here is the reciprocal of net primary productivity of the region. This term is nothing more than local NPP. It is the reciprocal of local productivity. And with this calculation, you will derive an area per person in hectares for food, vegetable food. Now, the same calculation could look like this, but remember, you don't need to actually carry out the calculations. Just take in the big ideas, consumption components, and the importance of local productivity in the calculation. I'm following up on the local productivity term in the calculation I just showed you. You can see the net primary productivities for three locations here: a very productive location, a very less productive location, and then one in the middle with a medium level of productivity. If we use the high NPP value, a rainforest region, say like Brazil, then this denominator value will be large. Thus, the area of the footprint for vegetable food would be small. Whereas if the NPP is small, a desert region like Oman, then this denominator value will be small. Thus, the area of the footprint for vegetable food will be large. Remember that productivity depends on rainfall and temperature. The productivity of the land provides resources and thus influences the size of the ecological footprint. Keep in mind that it would require more land to produce the same amount of meat as vegetable food due to the loss of energy as you move through the food chain, due to the second law of thermodynamics. Thus, the ecological footprint calculation separates the land area to required vegetable food from the land area to produce meat. Let's plug some numbers into the calculation of the ecological footprint component for vegetable food. For this term, let's assume a person consumes 320 kilograms of vegetables in a year. For this term, let's assume they live in a productive region with an NPP of 2,000 grams per square meter per year. Now this is converted into 20,000 kilograms per hectare. You'll have to trust my calculation of this value. The ecological footprint for vegetable food in a productive region is 0.016 hectares. Now this value appears small, but this is an area that's twice the size of your classroom, just for vegetable food. Now if a person consumes 320 kilograms of vegetables, but lives in a desert region, an unproductive region, the footprint for food increases. Now this should make sense, because if NPP as a denominator value is small, see the difference here, then the division results in a larger area footprint. Now remember, the ecological footprint includes the carbon dioxide waste that each person is responsible for as a component in the calculation. I'm referring to the carbon dioxide released from the burning of fossil fuels. We're all responsible for carbon dioxide waste. Ecological footprint calculations include carbon dioxide because when we live sustainably, we must be taking our wastes into account. Let's look at how we incorporate CO2 waste into ecological footprint calculations. The calculation of the land area required to absorb the carbon dioxide waste is much the same as the food calculation. We look up the CO2 released per person value. This is not hard. Then we multiply by the reciprocal of local productivity. Plants take up carbon dioxide, so the local productivity can be used in this calculation just like it was in the vegetable food calculation. Now, the same calculation could look exactly like this, but remember, you don't need to carry out the calculations. Just take in the big ideas that there are consumption components like vegetable food, carbon dioxide, meat, paper, wood, and that ultimately all of these must be summed together as consumption components. Remember the importance of local productivity. A less productive area as a denominator value makes the footprint larger. Here's a sample calculation for carbon dioxide waste. North Americans emit 19,000 kilograms of carbon dioxide per person per year. I know that seems astounding, but it's an accurate figure. For local productivity, I've used the productivity of the temperate deciduous biome, 1,200 grams per square meter per year, converted to 12,000 kilograms per hectare. The footprint for carbon dioxide uptake is 1.6 hectares for the average North American. Now, this is very large, and so it is. When we work through ecological footprints in class, the footprint for carbon dioxide is invariably the largest component. Here's an example of how to calculate the land area required for a person's paper consumption. Paper consumed in kilograms, easy to look up, multiplied by a conversion factor of wood per paper. Now, these conversion factors are available, they're not hard to find, then once again multiplied by the reciprocal of local productivity. Here's the calculation for meat consumption, meat consumed per person per year, multiplied by the reciprocal of the amount of meat we can grow per hectare. Now, the kilograms of animals per hectare is a far smaller value than the amount of plant material per hectare. The kilograms of animals per hectare that we can grow should be approximately 1/10 that of the plant material grown per hectare. You should know why. When we choose to eat meat rather than vegetables, our footprint increases because we're dividing by a small value of meat that we can grow per hectare. Remember that if the region is of low productivity, then our local productivity value will be small, making the overall footprint much larger. If the region is of high productivity, the NPP will be larger, making the overall footprint smaller. An accurate ecological footprint calculation would include as many components of one's consumption as possible. Now, what components are missing from the calculation? What estimates are being used in the calculation? For example, how are the resources that we obtain from three-dimensional space of the ocean incorporated into land area terms? And do we really factor into the calculation all of the items that we consume? What's missing among the items consumed that would typically be unaccounted for by an ecological footprint calculation? Is carbon dioxide the only waste that should be accounted for in an ecological footprint calculation? What about herbicides and pesticides? And could we incorporate soil degradation into a land area equivalent? And so that brings us to the end of our look at ecological footprint calculations. Let's move on to the next part of this movie. Here's the next IB syllabus statement of this movie. Describe and explain the differences between the ecological footprints of two human populations, one from a developing LEDC and one from a developed region MEDC. Here is a bar chart of ecological footprints in hectares among a select group of countries. Why would the US have such a large ecological footprint while India has such a small ecological footprint? Could you explain this? You should be able to do this. This line is known as the global biocapacity. This is the hectare value, just above 2 hectares, that is thought to be the average area, the average footprint per person, if every one of us consumed at exactly the same level. Or, in other words, if we took the world's entire productive land area and divided it evenly among the world's population, we would each have 2 hectares from which to derive our resources. Here's another bar chart comparing the ecological footprint of certain countries. Notice the U.S. footprint is huge, and that's because of the large combustion of fossil fuel component in the ecological footprint of American citizens. The U.S. is responsible for 25% of the world's carbon dioxide emissions, with only 5% of the world's population, and this largely explains why the ecological footprint of the U.S. is so large. Notice that China's ecological footprint is 2 hectares, but as China, or any country for that matter, develops its economy and raises standards of living, ecological footprints will increase. Now, all of these countries have high standards of living, and at one level we wish that for everyone on the planet. But there's not enough planet for all of the world's population to live at these consumption levels. That these countries have exceeded their fair share means that the people in these countries have borrowed, and I say that a bit euphemistically, resources from the land in these countries. But don't forget that while ecological footprints strongly represent the consumption pattern of the society in question, ecological footprints will be larger for individuals living in desert regions simply because the productivity value used in the calculation is smaller. This is a terrific graph that breaks the ecological footprint of various countries into the components that sum up to the total ecological footprint value. You can see that the land area required to take up carbon dioxide waste represents the largest component for most countries' ecological footprint. You could spend a lot of time with this slide. Please do so. 2 thoughts. How is the area for fishing ground calculated? And notice that Afghanistan and Sierra Leone apparently have no carbon dioxide emissions in their ecological footprint. Were their carbon emissions so small as to be negligible? Remember that in LEDCs, people do not have access to a personal vehicle or motorized machinery. Here's an IB syllabus statement. Ecological footprints may vary significantly by country and by individual and include aspects such as lifestyle choices, productivity or food production systems, land use, and industry. If the ecological footprint of a human population is greater than the land area available to it, this indicates that the population is unsustainable and exceeds the carrying capacity of the area. This is a nice graph because not only does it show per capita ecological footprint for various countries, but on the x-axis it shows the relative size of the population. Notice that India and China are both over 1 billion people. Their per capita footprints are relatively small. Now, is there enough land area on the planet to support all the Indians and the Chinese if the Indians and the Chinese consumed like U.S. citizens? No, there's not. So what do? We need to raise the standards of living for people in LEDCs while working very hard to lower the consumption patterns of people in MEDCs. The average per capita ecological footprint of people in MEDCs is larger than the per capita footprint of people in LEDCs because people consume more in MEDCs. It's that simple. More carbon dioxide emissions, more food, more meat, more paper, wood, cotton, etc., etc. This is another terrific graph because it shows the ecological footprint of various regions across the globe. It also shows the relative size of those regions along the x-axis, but it also provides information about the biocapacity of the region. The biocapacity, shown as these dotted green lines, is a function of the productivity, the NPP, of the region. Now, take some time to study this graph. There are a couple of things to note. The per capita footprints of people in North America and Western Europe far exceed the biocapacity of the region. And this is an indication that North American and European populations have exceeded the carrying capacity of the region. These populations are living unsustainably because per person consumption is high. But notice that the per capita ecological footprint of people in Latin America is well below the biocapacity. That's because of two factors: lower per capita consumption in LEDCs and higher productivity of the land, specifically warm, wet tropical lands. Lastly, notice that the Asia-Pacific, like North America and Western Europe, has exceeded the biocapacity. It's not because the per capita consumption is high. It's not. See how small the ecological footprint is. Asia has exceeded biocapacity because of large numbers of people. Having exceeded the biocapacity, Asian populations have also exceeded the carrying capacity of the region. Remember, going back to the beginning of this movie, that the land area required for the people of the Netherlands is greater than the land area available. If the ecological footprint of a human population is greater than the land area available to it, this indicates that the population is living unsustainably and exceeds the carrying capacity of the area. The ecological footprint is a model to estimate the demands that human populations place on the environment. If the ecological footprint of a human population is greater than the land area available to it, that indicates that the population is living unsustainably and exceeds the carrying capacity of the area. Here's my last graph of the movie. Again, this is a great graph, one that should be studied. It displays per capita ecological footprint on the y-axis against available per capita ecological capacity on the x-axis. Now notice that India has a low ecological footprint, a small ecological footprint. This results from being a less economically developed country. Indians on average are not large consumers. But India has a low per capita biocapacity. This results from high population numbers, over 1 billion people. Now New Zealand has a high per capita ecological footprint. New Zealand is a more economically developed country. New Zealanders are high consumers. But New Zealand also has a high per capita biocapacity because New Zealand has very productive land and very low population numbers. Again, the ecological footprint of a country depends on per capita consumption, population numbers, and the productivity of the land. As a function of all three factors, countries below this line are living within the biocapacity of their region. Countries above the line are living above the capacity of their region. Countries above the line are living unsustainably, having exceeded carrying capacity of their region. As a last note, any conservation of resource, reduce, recycle, reuse, remanufacture, would reduce one's ecological footprint, turning off the lights, carpooling, public transportation, consuming less of everything, wasting less. Any conservation measure reduces one's ecological footprint. Remember that carbon emissions arguably represent the largest portion of any ecological footprint. Alternative energy forms, wind, solar, hydro, nuclear, would reduce the ecological footprint. And as I wind this movie down to the last few slides, I want to note that the relationship between development and ecological footprint is a controversial one. There is only one Earth, so every population that has exceeded its available area is, in effect, borrowing land from places living sustainably under their capacity. And is this fair? In this graph by the UN Development Program of per capita ecological footprint and the Human Development Index, you can quickly see that all the countries with a high Human Development Index are populations with large ecological footprints, and populations with low per capita footprints are places that are poor and underdeveloped, ranking low on the Human Development Index. Is it fair that some populations consume at high levels and live well, while others do not? And that brings us to the Millennium Ecosystem Assessment. The Millennium Ecosystem Assessment is a major assessment of the human impact on the environment, called for by the United Nations Secretary General Kofi Annan in the year 2000 and published in 2005. It popularized the term ecosystem services, the benefits gained by humans from ecosystems that are intact, not degraded. In this slide, you can see that ecosystem services directly influence human well-being. Regulation of climate, water, disease, supporting primary production, including soil, and the direct drivers of change that influence ecosystem services are species introduction or removals, external inputs such as fertilizer, pest control, irrigation, and resource consumption. So here's the IB syllabus statement on the Millennium Ecosystem Assessment. Factors such as biodiversity, pollution, population, or climate may be used quantitatively as environmental indicators of sustainability. These factors can be applied on a range of scales from local to global. The Millennium Ecosystem Assessment gave a scientific appraisal of the condition and trends in the world's ecosystems. Condition and trends in the world's ecosystem, and the services that they provide using environmental indicators, as well as the scientific basis for action to conserve and use those ecosystems sustainably. And that brings us to the end of IB ESS Intro to Resources, Part 7.